Hello everyone. We are doing series of videos to arrive at trigonometric ratios of specific angles. Earlier video, trigonometric. I always make this, yeah. Uh, in our earlier video, we arrived at sine 0 degrees, sine of 0 degrees. We arrived at the value of sine 0 and we found that it was equal to 0, and at the same time we also arrived at sine of 90 degrees and we found that this was equal to 1. In this video, let us find what is cos 0 degrees and what is cos 90 degrees using the same technique which we did for the previous two ratios. Now let us find out what is cos 0 degrees. How is cos defined? How is the cosine of any angle defined as a ratio? It is the adjacent side by the hypotenuse. The cosine of any angle, say theta, is the length of the adjacent side, the one which is adjacent to theta. So if this is theta, it is the length of the adjacent side divided by the length of the hypotenuse. This gives you the value for cos theta. So, and it is the same for any angle as we saw before, because all right angle triangles with the same theta, if theta is the same, they are all similar to one another. So let us try doing arriving at cos theta. We need a right triangle, so we have this triangle now. Let's try with this triangle. I'll place it here. So what should we have in mind? Keep in mind the length of the adjacent and the length of the hypotenuse when theta becomes equal to 0. So first we are going to make theta to be equal to 0 and find out what is the length of the adjacent and what happens to the length of the hypotenuse. So this is the 90 degree. This place is a 90 degree and this is going to be our angle theta. Let me mark a small dot here. So let us assume that this is angle theta, and now we are going to make theta towards 0 degrees. We are going to decrease this angle here and make it 0 in order to find what is the length of the adjacent and what is the length of the hypotenuse. So let me start reducing. See, as it reduces, what is happening to the adjacent and the hypotenuse? When we were doing sine, we had our eye only on the opposite side. Now we should have our eye on the adjacent side. So what is happening to the adjacent? The angle is reducing further and further. I think almost theta would be now equal to say 10 degrees. The opposite is vanishing. Yes, not a concern. What's happening to the adjacent and hypotenuse? They are going to collapse into one another, isn't it? They are almost becoming equal now. The length in between is decreasing. It's decreased further, and now totally there is no gap in between and they have collapsed one into the other, and the triangle is now nothing but a straight line, but our purpose has been achieved. We have here at this place we have a 0 degree now. So what is the adjacent and what is the hypotenuse when this theta has become 0 degrees? Whatever the length of the adjacent and whatever the length of the hypotenuse, they are going to be equal to one another, isn't it? So cos 0 degrees, by definition it is length of the adjacent by length of the hypotenuse. They are now equal to one another. Both are equal. If the numerator and denominator in a fraction is equal, what happens to the fraction? Both the numerators and denominators get cancelled and the fraction becomes equal to 1, isn't it? So now we have this conclusion: cos 0 degrees is equal to 1. Now let me repeat the same procedure for cos 90 degrees. What happens when this theta increases further and becomes equal to 90 degrees? Now let us take another triangle. Yeah, this one. I'll shift it down because we need some space to move around here. So it's here. Now can I... Yes, let me make it to a normal triangle, a normal right angle triangle. it is right angled here at this side, and this is theta, and we are going to make theta to be equal to 90 degrees. Of course, you can't imagine a triangle with the 290-degree angle. It's not possible, because the sum of the angles in a triangle is equal to 180 degrees, and in a right angle triangle already we have a 90 degree. So the other two angles should add up to 90 degrees. So what if just one angle is 90? It becomes a straight line, of course, but we just want what happens when when theta becomes 90 degrees. We would like to find the value for cos 90. So let's try making it 90, though it won't be a triangle anymore. So what our purpose is to, wherever this blue dot is, we'll have to increase the angle. So am I increasing the angle? Yes, it is increasing. The angle is increasing and it is tending towards 90. Let's have an eye on the adjacent and the hypotenuse when theta becomes 90 degrees. Now, which is the adjacent, which is the hypotenuse? Recollect using this figure here. When theta becomes 90, the black, where I am pointing the red line, this becomes 90. This is the adjacent and this is the hypotenuse. We'll have to have an eye on these two lengths. What happens to these two lengths when theta becomes 90 degrees? So let's have an eye on it. So yeah, the adjacent is diminishing. It's nothing. It is just decreasing and decreasing and decreasing, and when theta is becoming 90 degrees, now totally there is almost nothing. But when theta becomes 90, adjacent has vanished completely. There is no adjacent side. So what happens when theta becomes 90? What happens to cos of 90 degrees? What happens to the ratio? The adjacent becomes 0. It's defined as adjacent by hypotenuse. The length of the adjacent becomes 0. And now whatever the hypotenuse is, we are not concerned about it, because whatever the length is, 0 divided by any number is equal to 0. So now we conclude that cos 90 degrees is equal to 0. So cos 90 is 0 and cos 0 is 1 is the takeaway for us from this video. Now what we are going to do is, we have created a table. Yeah, we have created a table, and we're going to fill in values whichever we have found so far. So what have we found so far? In the first video, we saw that sine theta, when theta becomes 0 degrees, sine 0 degrees becomes equal to 0. The value of sine 0 is 0, right? I have listed all the angles which we are going to find the values for. The trigonometric ratio values for in the top column, 0, 30, 45, 60, 90. This first row denotes the angles, and the column here denotes the sine of the theta, the trigonometric ratio when sine takes 0 degrees, when the angle, the sine of the 30 degrees, the sine of 45, and so on. So far we have found sine 0, it is 0. And we found sine 90, it's equal to 1. And we've also found in this same video, the first part of this video, cos 0 degrees was equal to 1, isn't it? And cos 90, we found it out to be 0. This is all what we have found till now. One by one, we'll find the other ratios. But look at tan theta. How is tan theta defined? Tan theta is equal to sine by cos, isn't it? Tangent of theta, the ratio is equal to sine theta by cos theta, because we define tan theta as the opposite, the length of the opposite side by the adjacent side. So it takes the value of sine theta by cos theta. So let's find what happens to tan 0 degrees. So we'll do it one by one. What happens when the angle takes 0 degrees? Tan 0 degrees becomes equal to 0 by 1. So 0 divided by any number is 0. So let us put 0 here. And what happens when theta takes the value of 90 degrees? Tan 90 degrees becomes equal to 1 by 0. But division by 0 is not defined. That is why here we'll have to mention tan 90 degrees is not defined. because we haven't yet defined what happens when a number is divided by 0. So tan 90 degrees is not defined. So we in this table have filled up values which we have found so far. I hope you understood. Thank you.